events not too far from here. Yes, please. In 1947. I'm sure everybody knows what this is all about. But, so basically, the topic of many worlds has been around for a long time, and you could say, okay, I think I might be able to get it now.
Okay.
Yes. You could say that it started as one of the first questions that philosophers on record asked. So the first guy who probably asked the question was this gentleman who lived in the 6th century BC, and his answer was probably not, I think. I mean, his question was, his answer was that there are probably no aliens in that sense. There are no other worlds than ours. But about 100 years later, the atomists came up with a philosophy where it made a lot of sense to believe that, yes, the universe, in fact, was full of many things. This multiplicity within the universe was a fundamental property. And this idea was taken over by a very influential and quite popular school of thought throughout antiquity, the Epicurean school. So quite often what people hear is that, in fact, this Epicurean or atomistic idea of many worlds, in fact, is a precursor of the many worlds that we think of today, but it's a very different idea, in fact. If you think about it a little, you'll find that, in fact, what they meant was that you had multiple universes, in fact. Each of these worlds, each of these cosmoses was made had a similar structure to our own. In other words, the way they pictured the universe was that you had something like the Earth in the middle, various planets whizzing around it, and then you had a sphere of fixed stars. So in fact it was a nice little globular thing, and there was an infinity of such globular things in the universe. So this was in fact the form of cosmic pluralism that the Epicureans were known for. The next stage, if you like, in the development of this thought came in the 15th century with a gentleman called Nicholas of Cusa, and he came up with a very revolutionary idea. He said that the Earth was in fact a heavenly body. It was a star. In other words, it was like other heavenly bodies, or perhaps you could put it the other way, that the heavenly bodies are like the Earth. And looking at it from this perspective, you'll find that in fact it is quite natural to assume that since the Earth is inhabited, and if the Earth is a heavenly body, then the other heavenly bodies might also be inhabited. So this was his big input into the discussion. He basically came up with the idea that the Earth is a star, and therefore all stars are like the Earth, having inhabitants. We can we'll get back to this and the details of this a little later. And then shortly afterwards, relatively speaking, only because this idea is separate from this one by nearly 2 millennia, right? But here it's just 2 centuries. So Nicholas of Cusa published his book in 1440, and around the year 1600, the idea came to Giordano Bruno, and then more importantly to René Descartes, that in fact the sun is like the stars but like the fixed stars. Or the other way around, the fixed stars are like the sun. And this means that if there are planets whizzing around our sun, there are planets whizzing around the fixed stars. So the fixed stars are not just little pieces of light scattered on a sphere, but they are in fact similar to our own sun, and similar also in the way that the sun is a center around which gravitate planets. So in fact, before this idea, there was no place for planets outside of this solar system, if you like. There could have been planets in the other universes, right? But each universe had its own sphere of fixed stars, and the fixed stars were just little dots of light. Okay, so let's step back a little bit and look at why and how these people thought about these things. So the question is, which you can't really see, I'm afraid. It worked before we started. So what was philosophy in antiquity? What was its goal? You have two options. Was it A, to learn about the world, or was it B, to know how to live well? Who's for A? Okay, there's some hands. Who's for B? Oh, yeah, many more hands, and you're quite right. It's the second theory. The philosophers of antiquity were not interested about the world as such. They were only interested in it as a function of creating a worldview, if you like, creating a philosophy of life. And philosophy means, in fact, the love of wisdom, the wisdom of how to live correctly, how to live well, how to be faithful to whatever purpose you might have. So, in other words, how does this tie in with our story about these different types of cosmic pluralism? Well, the Epicureans, in fact, built on the idea of the atomists, that in fact the world has no meaning, no purpose. The world is simply a chaotic dance of atoms in a void. There is no rhyme or reason to it, and there is no point in trying to find any. The only point that there is, perhaps, in your own life could be that since there are no higher levels of values, you should lead your life in a way that minimizes your suffering in a sustainable fashion, and that you should value your friends. Basically, with these two tenets, you have the very coarsely put idea of what this life wisdom, according to Epicureans, was. So, the whole point was not to say that the world, is made of these multiple universes and all that. The point was to say that the world is chaotic. There is no rhyme or reason to it. And that, in fact, you have this irrepressible multiplicity of things that is basically completely and utterly devoid of meaning. And in fact, with this gigantic number of things, you just can't figure out what is the meaning of it all, because there is no unifying idea behind it. The philosophical schools that were predominant, on the other hand, in antiquity, and in fact even today, look at the world in a very opposite way. They say that the world does have some sort of a meaning, and that you can actually try and understand that meaning. So, that is essentially the tradition that is represented by the names of Plato and Aristotle. And in this tradition, the idea behind the Epicurean philosophy is quite abhorrent. In fact, the idea behind Plato and Aristotle's philosophy is that there is this oneness to the universe, and there is a fundamental unity of things. In fact, if you think about it, science manages to teach us some of that by showing, for instance, that chemical elements are the same throughout the universe. So, in fact, one of the underlying principles of modern science is that the laws of physics are the same throughout the universe. You have to assume that, otherwise you can't really do anything. And this is precisely the sort of thing that an Epicurean wouldn't accept. They would question it, and they would say that you're making unreasonable assumptions. But with Plato and Aristotle, this is the fundamental assumption. The world does make sense, that the world, in fact, is fundamentally one, and that you, in order to live a good life, should somehow try to be one with that one universe. So you see now where the problem is. These guys, the majority if you like, were in fact dead against multiple universes, because multiple universes in their mind were connected to the philosophy they didn't like, the philosophy of this chaotic dance of atoms in a void. So, in fact, the reason why even today there are people who think that if you find alien life somewhere, you would automatically upset all religions, is this. It is really fundamentally an issue of a legacy of these philosophical schools of antiquity. So, in fact, just to show you that the story is in fact a little more complex, in the 13th century in Paris, it became extremely popular to start teaching in the Aristotelian way. And it was so popular, in fact, that some of the teachers went probably a little too far, and they needed to be reined in a little bit. So the Bishop of Paris condemned 219 propositions that were, Aristotelian, if you like. And these propositions, some of them, were in fact things that you might recognize. Proposition 34, for instance, is that the first cause could not create many worlds. Aristotle claims that, in fact, there is the multiplicity of universes is impossible, logically. And the church said at the time that you shouldn't limit divine freedom on the basis of philosophical speculation. God could have created any number of universes he wanted. So in fact, in a very roundabout way, you get an affirmation of cosmic pluralism, of at least the possibility of it, not necessarily an affirmation of cosmic pluralism as such, because I'm pretty sure that Bishop Dampier didn't really think that there were any aliens out there. He just said that you shouldn't base your outlook on the world on simply philosophical speculation. There are more things out there. So, in fact, if you think about the legacy of all this, we still have certain aspects of it present in our thought today. So the Epicurean multiple universe cosmos, in fact, today is quite a fashionable idea in some cosmological circles, that you might actually have many universes, 10 to the 500 or something like that, universes, and that would sort of explain some of the paradoxes of the fine-tuning of our universe. The idea of Nicholas of Cusa that in fact the Earth is a star, that it's a heavenly body, that there is really no fundamental difference between the Earth and the sky. This is something that, curiously enough, is still not quite with us today. We are sort of getting used to it, but generally speaking, our whole culture is still imbued with the idea that the Earth is somehow fundamentally different. If you look at astronomy pictures, of course, there's no problem. But if you look at the language we use, we still assume that there is a good meaning behind things like up and down. There isn't. And it's very difficult to get this in our way of thinking. And of course, the cosmic pluralism that I'll be talking about most part of this lecture is the cosmic pluralism where in fact you are looking for planets outside of the solar system, planets orbiting other stars. And this is an idea that dates back to the beginning of the 17th century. I was just trying to give you a very brief introduction into the history of this topic. You might have heard this story presented in different ways. And in fact, this is also quite well documented. It's an issue that you may have come across in this setting before. An issue where essentially there is a legacy of historiography that was really ideological. Historiography where people were trying to claim certain things without necessarily actually having good arguments behind them, but they were basically trying to say that religion was always a bad thing, and it was trying to thwart the development of science, development of humanity as such. So the canonical, let's say, history of this topic never mentions Nicholas of Cusa. On the other hand, it mentions Giordano Bruno as a martyr of science, and he was supposedly burnt at the stake because he proposed cosmic pluralism. Now, he was burnt at the stake in the year 1600, and that's quite a lamentable fact, but it was definitely not because of his ideas on cosmic pluralism. It really had nothing to do with that. So Giordano Bruno is the person that you hear about in this story, but in fact, his influence, if you look at his contemporaries and the generations that came after his death, was minimal. In fact, the person who really did make a splash, if you like, in claiming that the sun is like the stars, or rather the stars are like the sun, the fixed stars, that was in fact a follower, or perhaps a propagator of the thought of Cartesius, René Descartes. And this was this guy, Bernard de Bouvier de Fontenelle, who published in the year 1686 a bestseller that came out in very many editions. It's basically, the best translation would be something like Dialogues on the Plurality of the Worlds. And this is a book that became, like I said, quite popular, and people sort of started thinking about aliens living on these planets, whizzing around other stars. Nicholas of Cusa, on the other hand, was sort of overlooked because he didn't fit in the mold that the story needed. You see, he published in the year 1440 a book where he said that the Earth was not at the center of the universe, that the universe could be infinite, that the Earth was of the same nature as the stars, and I've said that already, that there is no perfection in the physical universe, the celestial spheres cannot be perfectly spherical, and that the stars were habitable, and there were many non-human extraterrestrial beings inhabiting the stars. Now, from what you've heard does this type of a book strike you as something that would be welcome in the Middle Ages? No. Well, you are completely and utterly wrong. In fact, it was because of this book, among other things, that this guy made a great career. He was created cardinal in 1448. Okay. So in fact, saying things like this was not a big deal in the 15th century. It may have become a little bit of a problem later, but not in the 15th century. Anyway, so the guy, as I said, doesn't fit in the canonical story, and therefore he is just omitted from most of 19th century histories of astronomy and of science, Western thought in general. But historians today are a little more serious, and they try to have as few preconceptions as possible, which is of course always difficult. So they've started publishing works that are a little more objective. Anyway, Nicholas of Cusa's Aliens. I love that little passage in his book, because he says that these aliens can be completely different from us. There is no reason to believe that they are similar to us in any way. So, for instance, the inhabitants of the sun are full of light and grace, and they probably didn't even need to be saved. The inhabitants of Mercury are a little mercurial, so the inhabitants of Mars, those are warlike, and we won't go into what the inhabitants of Venus do. The inhabitants of Jupiter are very noble, and anyway, so basically, but this is, he was just putting that as a sort of an example. And the important thing for us is to realize that, for him, it was quite acceptable to say that, in fact, the relationship of God and these aliens could be completely different from God's relationship to us. Okay, let's go back to New Mexico. Some of you may know what this is about. I apologize. It has to do with Los Alamos. This cartoon was published in the New Yorker of, I think, May 1950. And as you see, it proposes an interesting hypothesis as to why there are no dustbins in New York. The magazine appeared in Los Alamos in summer of 1950, and with all these geeks around, basically what it boiled down to was that they started talking about whether this was a possible interpretation of the lack of dustbins. In other words, whether there could be interstellar travel. And 4 gentlemen went to have lunch together. You can see they're quite important names. And as they went there, they talked about these aliens and their possible spaceships reaching the Earth. And then, they started talking about other things. But Fermi, Enrico Fermi, came up with a question after everybody has already sort of half forgotten that they were talking about the aliens, because everybody was talking about something else. And Fermi, all of a sudden, apparently, exclaimed, "Where is everybody?" And it's great that the people at table with him actually understood that what he meant was, how many advanced communicating extraterrestrial civilizations are there in the galaxy? And that he must have calculated it in his head while they were having the first course, and that he estimated that there must be too many of them, in fact, for us not to observe them. So Fermi's estimate was something like there are 1 million, communicating advanced civilizations in the galaxy at any given time. So there is 1 billion of them. Where are they?
Far away.
Well, some of them may have dropped on Roswell, but anyway. So this is what is called as the Fermi paradox. The first solution to the Fermi paradox was proposed by a gentleman from the next table, who happened to be Hungarian himself, so it's fine, because he said that they are amongst us and they call themselves Hungarian. And since then, you've had a lot of different hypotheses and theories as to why we don't see all these aliens. And there is a nice book by Stephen Webb which sort of lists all these possible answers. Anyway.
Did you go back to it?
Okay, they are here and are meddling in human affairs. They were here. They are us. We are aliens. They are here and they are watching us. We are in a zoo, like animals in a zoo. Or they are not watching us, but they have some sort of a prime directive not to interfere with us. And then there is this planetarium hypothesis that in fact the universe we observe is not a universe at all. It's a projection. All the photons coming to us, supposedly from the stars, are in fact coming from basically a very sophisticated projection system that is put in place to confuse us and to make us basically do things. It's like rats in a maze. Okay, now let's very briefly look at the approaches that contemporary science has to this question of are we alone in the universe. So I'll mention several very briefly. So the search for extraterrestrial intelligence, of course, means that you are looking for signals using VLA or something. In fact, the program of the SETI Institute has been ongoing for 53 years now, I think, and essentially nothing much was found. But if you look at the phase space that you have to explore, it's not all that surprising. In fact, this program needs to continue with better equipment. And of course, somebody needs to fund it, which is always an issue. A completely different approach is represented by biologists and chemists and so on, who are trying to find out, number one, how did life emerge on this planet, and number two, how to make life in a laboratory. So this is an approach that comes and goes in waves. There are people who are doing it today, but essentially it's very difficult. The emphasis in the 1950s was great when an experiment showed that you could produce very easily amino acids in a laboratory setting. But to go from there a little further, you run into difficulties, and essentially, the biologists have been, for the most part, a little skeptical about this. So, another approach is to look for traces of aliens in the solar system. So, solar system exploration. American Southwest is also famous for the Lowell Observatory outside of Flagstaff, Arizona, where Percival Lowell created this wonderful globe of Mars with all these canals, that the Martians have used to irrigate their fields. Of course, we still continue in the same vein in many ways. We still send probes to Mars and trying to find out whether there are any Martians. But what should we be looking for? So another approach that is quite popular within the broader astrobiology community is to try and find how can life be isolated, perhaps, and where not to look. So, if you are trying to find traces of life, you want to look in places where life might exist, and not to look in places where it can't exist. So, that's sort of reasonable, right? So, what people started doing on Earth was looking in places where they thought there would be no life. And they keep failing, in the sense that they keep finding life in these places. So, deep sea vents, one place, microbes under Antarctic ice is another good example. There are microbes that you can bring to life after 200 million years of being embedded in rock salt. It's quite amazing. So at least terrestrial life is extremely hardy and it's very difficult to kill it. The thing is, perhaps the surface of Venus could be regarded as one of these places where you can't possibly have life, right? The temperature of 460 degrees centigrade, pressure 90 times the pressure of our own atmosphere. So, it's not really a nice place. On the other hand, we are organizing a conference in March next year on with the University of Arizona. It'll be a nice big conference with different people, search for life beyond the solar system. And it's a very technical conference. There'll be biologists there, there'll be people who design space missions within the solar system, but primarily outside of the solar, to search for life outside of the solar system. Obviously, the space missions won't go there. But we keep receiving mail from this gentleman who claims that in this very picture there are traces of extraterrestrial life. All right. We will quite happily have him present a poster at the conference. But I think that would be about the extent of our support for him. It doesn't look very, very likely to us. On the other hand, Mars has been a prime place where everybody is sending these nice probes trying to find some traces of life. And you know that there is good evidence that in the geological past of Mars, maybe as long ago as 4 billion years, there was liquid water there, which then disappeared rather quickly. Mars is much smaller than the Earth, and so it lost most of its atmosphere quite quickly. And therefore, anyway. So all these probes are looking for things. Now, another little quiz. There are, generally speaking, when you are looking for life in the solar system, one of the prime criteria is to look at bodies that have an atmosphere, fully developed atmosphere. So, what are the 4 bodies in the solar system with fully developed atmospheres? And I don't mean giant planets, because those are, terrestrial type bodies that have a good solid surface. So, solid surface and a fully developed atmosphere. Well, there's the Earth, right?
Venus.
There's Venus. We've already spoken about her.
Titan.
Titan. Somebody said Titan. Well, that sort of spoils my question. There's Mars. There's Mars over there, and that's Titan. So we know that Titan has a nice atmosphere. That's why the edge of Titan in this nice image is fuzzy. And we know that there are curious bodies of liquid on its surface. Now, these bodies of liquid can't possibly be water simply because we know the temperature there is minus 179 degrees centigrade. So, in fact, these lakes, maybe seas, are in fact made of liquid methane and ethane. So it would be very nice to have a look there, because if there are any critters in those lakes, weird fish, they would definitely be different from terrestrial life, simply because of the chemistry. You can't really have terrestrial life live in a lake of methane at minus 179 degrees. So you'd have to have a very different origin of life. And if you have two origins of life, two separate origins of life within the solar system, you are in business, because then you can say, you see, life in fact is a natural function of chemistry, and it just occurs anywhere it can. But at the moment we can't say that, because we haven't sent a probe inside one of those lakes, and we probably won't in the next 30 years, unless somebody decides to change their funding policies. Because the big mission will be to the system of Jupiter within the next 10 years or so. And in the system of Jupiter there is a body that is particularly interesting. It's Jupiter's moon Europa, which very probably has a global liquid ocean under a crust of ice. It has no atmosphere, but it has this crust of ice that protects the ocean, and you could have, conceivably, some thermal or chemical gradients on the bottom of that ocean, which could conceivably give rise to some...
what causes patterns?
Well, it's actually the ice cracks and water comes out. So it would be very nice if somebody actually managed to say, okay, land a probe right here, because it'll crack when the probe's there, and you can get a sample without drilling through miles and miles of ice. So why do these cracks occur? Well, I think it might simply be because of the gravitational pull of Jupiter, but I don't know. It could be that there is some form of volcanism on the bottom of that ocean, and that might, be simply an effect of the heat transfer as well. But who knows? That's why it's so interesting to send a probe there. Anyway, the topic that I want to cover in the remainder of this talk are exoplanets. And the first was discovered in 1995, and now we've got lots of them. Essentially, all these discoveries were made because careful observations of the stars allow us to say something about invisible partners that these stars might have. So stars wobble in the sky a little bit because there is a planet orbiting around them. And this wobble, seen from the side, allows us to use a method called the radial velocity method to basically identify the presence of a planet, or there is a conceptually simpler method. Simply, if the planet passes in front of the star, then the overall light from the system diminishes during the transit, and by carefully observing the light curves of the stars, you can detect planets as well. Now, if you have information from both these methods, then you can say that yes, you've found a planet and you've characterized it to the point of having a certain idea of its bulk density. So that's pretty good. But I don't want to go into the details of all this. Let me just say that now we've got 1,000 planets, the existence of which has been confirmed by independent methods. So, and in fact there are several thousand more candidate planets, planetary systems, where we still await some confirmation, because these might be false positives. So. Anyway, the thing is that we have very limited abilities to actually see those planets. What we do, in fact, as I've said, is look at the stars and carefully analyze the light of those stars without seeing the planet itself. There are some systems where the planets are sufficiently far away from the parent star where you can actually see the planets. So those are there's just a handful of those systems. So in fact, for practically all of those 1,000 planets that are confirmed and several more thousand, you can't actually see them with the current equipment we've got. They are just too close to their parent stars. And the parent stars are just too bright. So in fact, you just see the starlight. What we would like to do, though, of course, in the next stage, and that's one of the reasons why we are putting together this conference, is to figure out what to do to characterize the chemical composition of the atmospheres of these planets. Obviously, the way how to proceed is to do it spectroscopically. So looking at, in fact, how much of what color there is in the starlight, in the light of the planet, in fact, you can tell something about the composition of the atmosphere. So, in the solar system, just looking at rather crude infrared spectrum of three bodies, Mars, Venus is in yellow, and the Earth in blue, you can see that, in fact, the spectra tell you something about the composition of the atmosphere. So Mars has essentially nothing except CO2 in the atmosphere that you can see here. Venus has lots more CO2 in its atmosphere and nothing else. On the other hand, the Earth has a lot of water vapor. So there are features in the spectrum showing that. And there is also oxygen. You can see this ozone feature in the spectrum. So having CO2, H2O, and O3 in a nice plot like this, if we actually saw that from another planet, we would be extremely excited. Because, as you know, the oxygen in the atmosphere at such a high concentration is only possible because there is something producing it. Oxygen would, under normal circumstances, disappear from the atmosphere simply by chemically bonding with the rocks. And so the fact that we do have oxygen in the atmosphere is an indication that there is some other type of process, some process that we have basically not managed to come up with an alternative for. And the process, as you know, is photosynthesis. So, in fact, this is an ideal outcome. Of course, it's all wishful thinking, because even the history of the Earth, oxygen levels have grown only in the last 500 million years or so. So, in fact, most part, there is no reason to believe that even with the presence of microbial life, for a long time in the history of the Earth, you still wouldn't see anything in the spectrum. Anything that would be unambiguous. Because if you see methane, for instance, methane can be produced by other processes. Simply geology can produce methane quite nicely. What we want to do is to have a way how to sort the light coming from the star from the light which is coming from the planet, which is much fainter. As you can see, it is very much fainter. Now, in the case of the Sun and the Earth, in the visible it's 10 billion times fainter, and the infrared it's 10 million times fainter, but it's still pretty bad. We can see such faint objects in the sky, but not if they are so close to something so bright. So there's another little detail, namely that in a planetary system, including ours, there is dust, and this dust scatters light. So essentially, the whole thing is like observing a firefly which is flying around a lighthouse. The firefly is a foot from the lamp of the lighthouse. which is glaring at you, you are 1,000 miles away. There is fog everywhere, and you don't just want to know that there is a firefly there, you actually want to analyze its exact shade of the underbelly. So this is what we want to do. And in fact, there are three proposals of space telescopes that could do that. And it's been sort of demonstrated in the laboratory that they can do it. The only problem is the price tag. So, anyway. Are there any lessons that we can learn from these 1,000 planets that we've found so far? Well, one is that practically every star has planets. The second is that there is a completely unexpected diversity among those planets. That they are really different from what we would expect. And in fact, so different that there's no good analogue of our solar system out there, of those 1,000 planets. So, one more little detail that I want to mention. This is an artist's impression of what our galaxy looks like. If you look at those 1,000 planets, they are all in just that little region of the galaxy around the Sun. Because, naturally, the methods we use rely on the fact that the stars have to be bright enough. So we don't see stars that are further because they are not bright enough to our eyes. So the closer they are, the more likely we are to observe those planets around them. So, as you can see, all these numbers are extrapolated, in fact, when you've heard perhaps that, there was a paper that came out last month, that there are 8.8 billion terrestrial planets in our galaxy. That's an extrapolation from that. So, who knows? The fact remains that this is just one galaxy, right? There are very many galaxies. There are hundreds of billions of galaxies in the universe. So, if we are alone in the universe, it would be quite a waste of time. Anyway, so I think I'll end here and I'll leave you to ask these questions. Okay, thank you. So I understand there are two sorts of... There's just 5 minutes of questions first, and then there's...
Yeah, so the plan here is that we have a few minutes for general questions, and then everybody can go and enjoy the goodies that are over there, and in about 10 minutes we'll regroup, and people who wanted to have a more extended discussion can sit down here.
What's your next slide?
There's a few more slides there, but this one, in fact, has to do with an aspect of discussion. One of the perks of being a Jesuit is that you actually live with some interesting people. So I happen to live in Paris with some notable theologians, and this guy in particular gave me an interesting little answer that I wanted to share with you. So I asked him about things like, the theology of aliens. Well, he asked me, well, have you actually seen an alien? I said, well, not that I know of. Yeah, well, there's that. And he said, well, if you actually bring me an alien, then we can perhaps discuss theology with the alien. But before that, basically, he was not committed. And I think this is an attitude that most mainstream theologians have these days. They don't really consider this to be a pertinent question, and they develop all sorts of other things in theology, but not this. Yep.
I have a theological question, and if God is Trinity, Father, Son, and Holy Spirit, Jesus came as man and he's in human form in heaven, then how can there be aliens? Because there's only a Trinity, and then Jesus was in human form.
There you have it. This is precisely what I asked, right? And so essentially, the answer that, for instance, Nicholas of Cusa would give you is that, well, you can fit in aliens perhaps in that scenario as well, simply by saying, for instance, that they are like angels, that they didn't need the mediation of Jesus. So that's an option. But you could also say that, in fact, the economy of salvation is such that for the aliens, it's just different, and that perhaps our views of Trinity need to be expanded. So it's very much an open question, and I think until we find those aliens, we shouldn't really be wasting too much energy on that, because you know what might happen. There'll be these aliens who will come knocking at your door, in their best Sunday shoes, and they'll tell you all about this wonderful theology they've got.
Clyde.
Yeah, according to the Bible, we're created in God's image, according to the Emerald Tablet of Hermes Trismegistus, it says, as above, so below, and there are a lot of other, similar things. So why would it be unreasonable to think that a lot of aliens are, in fact, human?
Of course, why not? It's a good, legitimate question, and I can only tell you that by extrapolation I wouldn't find it particularly reasonable because of this.
I'm not saying that they
What we are finding in our research already in the solar system is that the diversity of the bodies in the solar system is much greater than we expected. And looking at these other solar systems, we are finding again an unexpected diversity. Obviously this is just on the level of astronomy. It's not even biology, let alone sentient life. But still, the universe seems to be abounding in diversity. So I would be rather surprised if aliens looked and acted like humans. Some of them might, but...
Also, there's a similarity too, like, if you take a typical, so-called gray, okay, they have 2 eyes, they have...
Oh, okay, I see.
And, like, they're very similar to humans, and if you look at the variation of humans, you have people of all different colors, different, physical features, just on our planet. So, it seems like even through our own life forms, there's certain symmetry of bodies, 2 eyes, 4 legs, and so on. I think that may also be found in aliens.
I'm not an evolutionary biologist, but basically what I've been told is that the adaptation is a function of the environment and of the physical properties of the environment. So if, for instance, those intelligent aliens happen to live in a liquid like water, let's say, or perhaps like the lakes of Titan, then they would necessarily have fins.
Yeah.
And you would expect them to have them. But can you say that they won't be intelligent? You see, this is the whole problem. So in fact, what I'm pointing out here is the diversity of the environments that we are likely to encounter. And if the environments are diverse, then the body forms will be diverse. Yeah?
Well, the morphology is not important. Of course there's diversity, but there could be some fundamental, universal motivations for survival. We're all driven to gather resources to ourselves. We eat, we drink water, whatever we need to sustain ourselves, collecting shiny bits and pieces, reproduction. All these things might be more universal than we think. And so we start getting an evolution of complexity that may be along sort of universal lines that lead to consciousness and a human-like consciousness. these things that we take for granted, like love and generosity and evil and good, maybe more universal than we think, but goes beyond the morphology of these things. You see what I'm saying? The motivation that, you look at our own planets, how things are evolving, the complexity.
Yeah, I'm quite with you, and I think that this is a very valid point. In fact, there might be good arguments to say that, for instance, even with things like science, okay, in order to do science, you have to respect reality around you. You can't just say, well, I want it to be this way. No, you have to say, okay, this is the way it works out in the laboratory, and it's not what I thought, so I'm sorry, I have to start again. Right? And so you have to have some respect for this reality around you. It's not something that comes necessarily from an ethical standpoint. It's simply something that is imposed by science itself. Otherwise, it just doesn't work. So there might be something like that. In fact, the aliens we encounter, come on high-tech spaceships. They are very likely to have developed, perhaps, a similar type of an ethical attitude, simply because that's a prerequisite for developing those spaceships.
Survivability even.
So it's an interesting debate. But again, it would be, I'm an experimentalist. I would really like to see those aliens first.
The consciousness, the spirit is universal.
You've been talking about life, finding it somewhere else. What is life?
Brilliant question. We have no idea. And of course, this is something that is quite natural, because we only have one example of life, essentially. So if you have just one example of a phenomenon, you need to be very careful when you come up with any definition, because you don't know what is essential and what is just accidental. So it's a methodological limitation that we've got at the moment, and in fact it sort of makes it extremely difficult to launch any of these searches because we don't really know what we're looking for. In fact, when it comes to these guys here, okay, the reason why we are designing them this way is not because we have some preconceived ideas about life. It's because this is the way we can design them. In other words, they're not optimized to any preconceived idea of life. They are simply optimized to the level of technology we've got at the moment. So what we can do here is simply analyze these spectra. There we go. Analyze these spectra once we get them in maybe 30 years' time, when I'm sort of ready to retire. And once we have that, then we'll look at some of them and say, well, this one looks actually quite weird, and we can't find a good model how to produce that type of a spectral signature simply with abiotic processes. Does that mean that we found life? Well, of course not. It just means that we can't explain that particular spectrum. But it might mean that we should send a probe there. And that's for future generations to do.
Okay, one more question.
I get there would be, I guess the ultimate goal, would be to find other intelligent life. So wouldn't it, I know like some of the searches do this, but you would look for like the signals that an intelligent, a technological society would produce, like radio waves that I know we produce, and it radiates out into space. Wouldn't it be safe to assume another technological species would do this?
Well, yes. The only problem with that is the efficiency of the search. The problem is that it's very difficult to look at the whole sky and find that one source that produces something
Now
that.
at the right time, also.
Yeah, because this is a very good point. In fact, the radio emissions that escape the Earth from our own production these days are much less than they used to be. In spite of the fact that everybody's got a cell phone, we've managed to produce these radio waves in a way these days that is essentially more efficient, and therefore we don't leak so much into space. So in fact, the brightness, if you like, of the Earth has dropped. And it was just 50 years or so where the brightness peaked. You know, in astronomy what you do is you look at gigantic numbers of objects, hoping that you'll catch these sufficient number of these objects in one stage of development so that you could categorize them at least and analyze the development. Well, in this case, if it's just 50 years, I'm sorry, but that's just not going to happen. You don't have enough statistics for that. So in fact, this particular type of search is, I'm sorry to say, it's really a little bit like lottery. It's not just a problem with the technique itself, and you have to have very sensitive receivers and all that, but it's also a question of the fact that in the history of a civilization, the period when it is the brightest when it comes to these radio emissions is probably not very long.
With that, why don't we thank Father Gabor again.